have this oxidation number, right, in the equation. The oxidation number increases if you are oxidizing. This means multiple things. This could either mean the element loses electrons. Well, definitely means that. Definitely means it loses electrons. It could, but not all the time, means it adds oxygen. So if you are adding oxygen to something, you're oxidizing it. If you're losing hydrogen, because oxygens and hydrogens are antagonistic, if you're losing hydrogens, that could be oxidation as well. Doesn't have to be. So you don't need to look for, like we saw last class, it's not more complicated than what we saw last class, when we're just determining the numbers between the left and the right side and figuring out which one's oxidizing, which one's reducing, which one's the agent, right? It's not much more complicated than that. So other things to look for is an oxidation if you're adding oxygens, if you're losing hydrogens. Don't worry about half reactions yet. And then reduction is the opposite of oxidation. So and they both have to happen inside one equation. So for reduction, it's the decrease in the oxidation number, which means the increase in electrons, the loss of oxygen, or the gaining of hydrogen. So you see a lot of these will happen at the same time, but not all of them need to happen. If you have an equation without oxygen in it at all, it could still be redox. Cool, so here's the rules again for the oxidation states. We'll do some example, we'll do another example. First things first is to find the oxidation state of all of the different elements. So hydrogen, we know is +1, so we'll write +1. Sulfur would then be what? Good, -2. Now, oxygen is what? -2, good. Now, this NO3 has a minus charge totally. So what would this nitrogen then be? Good, +5. Because +5 minus 6 from the oxygens equals -1. The hydrogen, so here's another rule that I didn't specifically go over, is that even if something is in its elemental form, if it's an elemental form but an ion, such as H+, the oxidation number is +1. So that rule for the element being alone always applies unless there's a charge that overrides it. So, and this is H+, therefore the oxidation number would be +1. But if you look at 3s on the right side, this is elemental form, but there's no charge, therefore it's 0. Then we have NO, which oxygen's -2. What would this nitrogen be? Good, +2. And then we have two things we know and love, H and O. Cool. Okay, so now after you assign oxidation numbers to everything, your job is to compare the left to the right side, which ones are changing. So who can tell me which one is changing? One of them. One of the elements. Nitrogen, good. So nitrogen is going from +5 to +2. So is that being oxidized or reduced? Reduced, good. Reduced. And if it's reduced, it's the what agent? If you remember. Oxidize, good, it's the opposite. So oxidizing agent. So that means it's forcing the oxidation, forcing the oxidation of the other one. So we can look at the definitions of oxidation, or sorry, of reduction, and see them in action here. So NO3 minus, it becomes NO. It loses oxygens. That's another key for reduction, of losing electrons. It doesn't gain hydrogens, but it loses electrons and the number decreases. So that's usually indicative of oxidation, or sorry, of reduction. And then the other one, which is the other element that is changed? Good, sulfur. So sulfur goes from -2 to +0. Goes from -2 to 0. And this is being oxidized, meaning the number is going up. Also, oxidizing means you're gaining oxygen, which the sulfur is not gaining any oxygens, but also means reducing or decreasing the amount, or sorry, losing hydrogen. In this case, it's losing hydrogen. So you see how it has 2 hydrogens here, and here it has 0. So that's another way of thinking about redox by that definition. So also, since it's oxidized, is the what agent? Good, reducing agent. Good. All right, cool. And then that would be basically it on what you need to figure out in these kind of questions. So, yeah, got the hang of that. Any questions on that? Here we go. Let's assign oxidation states to all atoms in the following. These are so much fun. So CO2. Oxygen is -2. So we have, here's the way I like to do it. I go like this. I draw arrows underneath, and I go -2. I write the oxidation state for the element, not for the total of them. Since there's 2 of them, you're going to have -4. And then that means, what's carbon? +4. So this kind of smacks in the face everything you learned about charges and ionic bonds and covalent bonds. Because like, whoa, we're dealing with, this is covalent, we're dealing with charges now, what the hell? That's why it's like a pseudo charge. It's not, it's just an oxidation state, it's just state. So don't get too focused on it. So you can deduce the information. Of course, they all equal 0, just like ionic bonds do with the pluses and minuses added up, unless it tells you otherwise. And in B, it tells you otherwise. It tells you that the complex of NO3 is -1. This means we can just write this information here. O is always -2. And then we can use that to figure, and use the minus sign to figure out what's nitrogen. And you can even set up a little equation if it gets complicated. You could say nitrogen plus 3 times -2 equals -1. Nitrogen plus, or nitrogen -6 equals -1. Plus 6, plus 6, nitrogen equals 5. Ta-da. So in this case, nitrogen is +5. You could think about this in your head as well, because I'm sure this is not too bad for most of you. So you have -6 from the oxygen. You know that total, it has to equal -1. That means the remainder is +5. +5 minus 6 is -1. Easy enough? It doesn't get much harder than that. So we'll do more. Do more practice. Wait, I'm going to do this. Okay. All right. So this is what you're going to get. This is more involved. So here's what I'm going to do. I want to show you the answers. Close your eyes. Keep them closed. 1 second. 1 second. Open them. Nice. Well, at home, like, I'm not closing my eyes. I'm eating my chicken tenders. That's good. That's good too. All right. So let's do these. So KMnO4. All right. So what do we know? Someone tell me. What do we know? Perfect. Great place to start. O is -2. What else do we know? Good. K is +1. It's a group 1A. So now we can deduce the manganese from it. So you have potassium is +1 plus manganese plus 4 times -2 equals 0, since there's no net charge on this. So you have -8 plus manganese plus 1. So this, you do the stuff, and you figure out that if you do the stuff, and you figure out manganese has to be +7. Oh, Mn. So manganese is +7. So yeah, that's basically it for assigning oxidation states. So we'll do B together, and then I'll give you a minute to do C and D on your own. So for B, same things, same thing. We have hydrogen this time. So we know hydrogen is what? Good, +1. Oxygen is -2. Good. Sodium is good, +1. And then iron, we don't know, but we'll figure it out. So it turns out, so if you remember hydroxide, hydroxide is a -1 charge. And it turns out hydroxide's oxidation state is also -1 because it's composed of 1 oxygen and 1 hydrogen. when you add those up, -2 and +1, you get -1. So you have -1 in this hydroxide packet times 6 of them. So -6 plus the sodium, which is +4. And then that remainder is -2. So to cancel that out, you need a +2. This would be whatever these charges are, plus the charge, or the formal charge, not formal charge, plus the oxidation state of iron equals 0. So if you do this math, Fe equals +2. Like that. So another rule of thumb, well, not really a thumb, but never seen it. I've never seen a metal have a negative oxidation state, so they don't. But non-metals could have positive or negative. So keep that in mind. Okay, so I'm going to give you a minute or two to do C and D on your own, and then we will continue. And we'll go over them and then continue. This one's kind of difficult because you have to realize what it is. Now, NH4, we know from polyatomic ions, is ammonium. So ammonium has a +1 charge. So to figure out the formal charge of nitrogen in ammonium, you write NH4 +1. So if that's the case, then nitrogen has to be, if hydrogen is +1, then nitrogen has to be 1 less than 4, so it has to be 3. So since -3 plus 4 equals +1 as the total charge of ammonium, nitrogen has to be -3. So that's one way you can get hydrogen as nitrogen as -3, is by looking at it that way. And also we know obviously that oxygen is -2, all the hydrogens are +1, and the only thing we have left over is phosphorus, which you can look at it as the whole. Now that we have nitrogen, you can look at it as the whole compound of ammonium. This is called ammonium hydrogen phosphate. Or you can look at hydrogen phosphate individually and know it has a -2 charge. So hydrogen phosphate, HPO4 2-, and you can break it down by oxidation state here. So +1 for the hydrogen, plus P for the phosphorus, because we don't know, plus 4 times -2 for the oxygen. So you have -8 plus phosphorus plus 1 equals -2. So then this gets to 6 -1, 5. So phosphorus in this case is +5. I draw arrows just like I did before, going through the thing, the equation, and looking at the oxidation states. So oxygen, -2. What's lead in this case? Good, +2. Oxygen again, look at that, -2. What's carbon? Good, +2. What's Pb? Good, 0 by itself, elemental form, 0. Automatically something changed, so Pb went down, that means something else is going to change. Oxygen here, -2. What's carbon? Good, +4, because there's 2 -2s for the oxygen, +4 has to negate it. That was easy. We just figured out all of the oxidation states for every element in their products and the reactant side. The next step is we're going to draw a bracket, or 2 brackets. The first bracket is going to be between the thing that was either one of the things that's changed and the other thing that's changed is going to be the second bracket. So we'll go from lead all the way to lead, draw a bracket. So we can see lead went from 2 to 0. Was it oxidized or reduced? So reduced. So reducing is gaining electrons. Oxidation state decreases. So yeah, if you weren't right with the first one, it's the second one. But yeah, so good job. So it's reduced. So we write reduced. Okay, so it's reduced. And now also that means by default, it happens to be the oxidizing agent. That's just the definition. Whatever's being reduced, oxidizing agent. Whenever it's being oxidized, reducing agent. So now we can do the same thing. I'll change the color. Well, I can change the color. Nice. Well, I'll do this. What is this? Galaxy. All right. So it's pretty cool. All right. So carbon. Carbon's the other thing that's changed. So we'll draw a bracket in this cool hip color. Nice. So carbon was changed from +2 to +4. The oxidation state increased. Therefore, it is oxidized. Oh, I ran out. What happened? I ran out of sparkly ink. There you go. Oxidized. And therefore, it is the reducing agent.